Let's take a look at the answers to exam 3. Question 1, fill in the blank. A, value x equals c where f prime of c is equal to 0 or f prime of c is undefined is called a critical value. B, if f prime of 5 is equal to 8, then the function y equal to f of x is increasing. We know this because the derivative is positive. The 8 is immaterial, it's positive 8. C, if f changes concavity at x equals c, then the point c comma f of c is an inflection point. Of f. D, if f prime of c is equal to 0 and f double prime of c is negative, then f has a local maximum at x equals c. Now, a lot of people put absolute maximum at x equals c. You don't know that it's an absolute maximum because you don't know if f has multiple critical values. If it has multiple critical values, then the best you can guarantee is local maximum. In order for it to be absolute, you'd have to be given the information that there was only one critical value, which you do not have. Question E, the measure of a country's wealth distribution is known as the Gini index. All right. Question 2, true or false, assume f is continuous. A, if f double prime of x is greater than 0 on the interval a to b, then f is concave up on a to b. That is true. B, if f has an absolute maximum, then it also has a local maximum. That's true. All absolute extrema are local extrema as well. C, if f prime of c is equal to 0, and f is increasing on negative infinity to c, then f must be decreasing on c to infinity. That is false. This could just be a horizontal tangent that passes through, like something like that. So it's increasing here, and then it doesn't necessarily have to decrease, even though the tangent line would be horizontal right here. It could continue to increase. D, if f is a quadratic function, then f must achieve an absolute extremum. That is true. So you either have a quadratic function that points down and you have a maximum, or you have a quadratic function that opens up and it has a minimum. E, suppose f achieves an absolute maximum value of 63 at x equals 4. Then, for any x that is not equal to 4, f of x must be less than 63. That is false. You could have another value of x where 63 is obtained again. So let's say here's 4, here's 63, and then there may be another one over here, like a 7, where it's equal to 63 as well. So you could have the maximum occur at two different places. Question 3. Given the graph of f, determine the following. A, on what interval is f increasing? So this is just straight up increasing. So it's from negative infinity to 1 union 5 to infinity. Question B, on what interval is f increasing? So f is increasing when, on what interval is f prime increasing? F prime is increasing when f is concave up. So concave up is from 3 to infinity. C, find the x value where f has a local minimum. So that would be x equals 5. And then D, find the x value where f prime has a local minimum. So if f prime has a local minimum, then that means the graph of f is going from concave down to concave up. And that occurs here at the inflection point, which is x equals 3. All right, let's look at question 4. Compute the limits. So first off, you want to check to see if this is 0 over 0, and it is. So therefore, we can do L'Hopital's rule. Take the derivative of the numerator, take the derivative of the denominator, and then evaluate. So you get 5 times 1 to the 4th, and then 3 times 1 squared, and that's 5/3. Question B, the limit as x goes to infinity of e to the x plus 2x over e to the x plus 3x. Verify that this is going to infinity over infinity. It is, because the e to the x is going to infinity. So we can use L'Hopital's rule. So the limit as x goes to infinity of e to the x plus 2 over e to the x plus 3. It's still infinity over infinity, so we can use L'Hopital's rule again. And so this is now just e to the x over e to the x. Now this simplifies. Without L'Hopital's rule or anything else, it just simplifies to 1. So the answer is 1. Question 5. Let f of x equal x squared times e to the x. Find the intervals where f is increasing and decreasing. Find the x values of the local extrema, clearly identifying which is the minimum and which is the maximum. So to find the increasing and decreasing, we need the critical values. To find the critical values, we need the derivative. X squared times e to the x requires the product rule. So it's going to be 2x e to the x plus e to the x times x squared. I'm going to set that equal to 0. I can factor out x e to the x from both terms. That leaves me with 2 plus x equals 0. From here, I'm going to set each factor equal to 0. So x equals 0, e to the x equals 0, and 2 plus x equals 0. X equals 0 is good. E to the x is never equal to 0, so no solution from that. And then we have x equals -2. We have 2 critical values, so let's do the sign chart. Putting them in order, we're going to have -2 and 0. These come from zeros. And then we will test the values, and we'll find we have positives, negatives, and then more positives. Therefore, f is increasing on -2 to 0 union 0 to infinity. F is decreasing on -2 to 0. F has a local max at x equals -2 because that's where it went from increasing to decreasing. And then f has a local min at x equals 0. All right, let's look at problem 6. A university admissions department is responsible for sending out brochures to prospective students. Each year they have an annual uniform demand of 360 boxes of brochures. It costs $60 to store each box per year and $300 to place an order for brochures. How many times during the year should the university print more brochures in order to minimize the total storage and ordering cost? So first, let's start with the demand. The demand is going to be x times y is equal to 360, where x is equal to, let me write this out, x is equal to number of boxes ordered, and y is equal to number of times per year ordering is occurring here. So that's the number of times per year you're going to order boxes. All right, so now the cost is equal to the storage cost, and on average you have half the number of boxes you ordered on hand, and you have to store those, so that's $60 per box, and then it cost $300 to set up the printing for the ordering for the brochures, so it's 300Y. Alright, if you take the demand function and solve for y, you get y is equal to 360 over x. So I'm going to take that and I'm going to put that into the cost, and now cost will just be a function of x. Now simplify. So this is equal to 30x plus 108,000 over x. Take the derivative, and you get 30 minus 108,000 over x squared. Find the critical value by setting this equal to 0. So you get 30 is equal to 108,000 over x squared. Cross multiply. Divide. And take the square root. Because this is an actual quantity of things, it can't be negative. So you're going to order 60 boxes every time you order boxes. And then y is the number of times per year from the formula above. That's 360 divided by x. So that's 360 divided by 60, which is 6. So it's 6 times per year. Alright, let's look at problem 7. We need to use the second derivative test to verify the extremes on this one. A company manufactures tablets. The price-demand function for selling tablets is P is equal to 750 minus X, and the cost function is C is equal to 4,000 plus 220X. Question A. How many tablets need to be sold in order to maximize revenue, and what price per tablet will maximize the revenue? So first, let's create the revenue function. That is X times P of X. So that's going to be x times 750 minus x, which is 750x minus x squared. In order to maximize revenue, we need to find the critical values. So r prime is equal to 750 minus 2x. Set that equal to 0. So we get 750 is equal to 2x, or x is equal to 375. Verify that this is a maximum by taking the second derivative. So the second derivative is the derivative of this boxed function here, which is going to be negative 2. When the second derivative is negative, that means that r is concave down at that spot, which looks like this, which means we do have a maximum, and that's what we wanted. So how many tablets need to be sold in order to maximize revenue? 375 tablets. And then what price per tablet will maximize revenue? So we're going to plug that back into the price function. So it's 750 minus the number of tablets, 375, which is also 375. So $375 per tablet. Part B. How many tablets need to be sold in order to maximize profit, and what is the price per tablet that will maximize profit? So now we're looking for big P, which is revenue minus cost. Oops. So the revenue was 750x minus x squared minus 4,000 plus 220x. That was the cost function from above. When you simplify this, you get negative x squared plus 530x minus 4,000. Again, we want the maximum, so we take the derivative to find the critical values. Set that equal to 0. So negative 2x is equal to negative 530, or x is equal to 265 tablets. Verify that this is in fact a maximum by taking the second derivative. Second derivative is negative 2. Again, same reasoning. It's negative, which means p is concave down, which implies we have a maximum. And finally, what is the price that should be charged to maximize profit? We'll take the number of tablets and plug it into the price function, and that's $485 per tablet. All right, let's look at the integration part. Question 8, find each of these integrals. So A just works straight up. Add 1 to the power, divide by the new power. The antiderivative of a constant is just the constant times the variable. And then don't forget the plus c. Simplify and you get x squared minus 3x plus c. Question B also is just straight up. The antiderivative of e to the x is e to the x. The antiderivative of 1 over x is the natural log of the absolute value of x plus c. No u substitution or anything needed, just straight up work it. Question C, you had to do some work beforehand to get this one to work out. So it's the integral of 15 times x to the 4/5 minus x to the negative 1/2. And it's negative 1/2 because the x is in the bottom, so when it comes to the top, it's a negative. And then the question is, what is the exponent that creates a square root? It's 1/2, so it's x to the negative 1/2. Now we can integrate. So we're going to add 1 to the power. It's going to give me 9/5 divided by 9/5. And then we're going to add 1 to this power. Negative 1/2 plus 1 is positive 1/2. And so then we divide by that new 1/2. Then we're going to simplify this by multiplying by their reciprocals. So it's 5/9 times 15 times x to the 9/5 minus 2 times x to the 1/2 plus c. And then that simplifies to 25/3, the 5th root of x to the 9th minus 2 square root of x plus c. And you could have simplified this even more, but if you got this far, I give you full credit. And then question D, find the integral of 3x over x squared plus 1 dx. Well, in this one you needed to use u substitution. So we're going to let u be x squared plus 1. Then du is 2x times dx. Solving for dx, we get du over 2x. From this point, we're going to substitute what we have. So we have the integral of 3x over u times, make this substitution, du over 2x. The x's here cancel, and the numbers come out to the front. There's a 3 on top and a 2 on the bottom. So it's 3/2 times the integral of 1 over u du. The integral of 1 over u is natural log. So this would be the natural log of the absolute value of u plus c. And then we back substitute. And we get 3/2 times the natural log of the absolute value of x squared plus 1 plus c. And on this one, you could have even dropped the absolute values. Oops. Because x squared plus 1 is never negative anyway. Let's look at question number 9. Find the antiderivative of f of x is equal to 6x minus 3 that passes through the point 513. So to find the antiderivative, we take the integral of 6x minus 3, and that would be 6x squared over 2 minus 3x plus c which is 3x squared minus 3x plus c. Now we need to find the value of c so that the equation satisfies the point 5, 13. So y is 13, and then I'm going to plug in 5 for x. And once you do that and solve for c, you get c is equal to negative 47. So the antiderivative that passes through that point is y equals 3x squared minus 3x minus 47. All right, question 10. So given that the integral from 3 to 6 of f of x dx is 19, and the integral from 3 to 6 of g of x dx is equal to negative 4, find the value of the integral from 6 to 3 of f of x minus g of x. Okay. So first off, let's write what we're looking for here. And I'll use a little shorthand here. The integral from 6 to 3 of f minus g. Now, see, the limits are backwards here, so I need to negate the integral so that I can flip the limits. And now, it's really the negative of this integral that I want here. So that's the integral from 3 to 6 of f minus the integral from 3 to 6 of g, which is negative of 19 minus negative 4, which is negative 23. So the answer is negative 23. A, evaluate each of these integrals. So this one just works straight up. So this is going to be x cubed plus 3x squared minus 7x evaluated from 1 to 9. So this would be 9 cubed plus 3 times 9 squared minus 7 times 9 minus 1 cubed plus 3 times 1 squared minus 7 times 1. So it is 912. Question B, find this integral. So we need to use substitution. So I'm going to let u be 4x squared minus x plus 9. du is equal to 8x minus 1 dx. And dx is equal to du over 8x minus 1. Since it's a definite integral, we also need to substitute out the limits. So u of 3 would be 4 times 3 squared minus 3 plus 9, which is 42. And u of 2, which is equal to 4 times 2 squared minus 2 plus 9, which is 23. So the new integral is the integral from 23 to 42 of 8x minus 1 times u to the 5th times du over 8x minus 1. Well, this one worked out perfectly. 8x minus 1 cancels. And so we have the integral from 23 to 42 of u to the 5th du, which is 1/6 u to the 6th evaluated from 23 to 42. So it's 1/6 times 42 to the 6th minus 23 to the 6th, which turns out to be 534099585 over 6, or approximately 890165975.83. Either one of those answers would be fine. All right, question 12. Find the area bounded between the curves f of x equals 9 and g of x equals x squared. So first, I'll draw the picture. So x squared is the standard parabola. And then f of x equals 9 is a horizontal line at y equals 9. and they intersect here at -3 and +3. And you can see that by setting them equal to each other. 9 equals x squared gives me ±3. So the area that we are looking for is the area bounded between these two. And they never intersect again, so we're good to go. So area is the integral from the bounds, so -3 to 3, of the top one, 9, minus the bottom one, which is x squared dx. And so we integrate, we get 9x minus x cubed over 3. We evaluate that from -3 to 3. And let me do that up here. So that's going to be 9 times 3 minus 3 cubed over 3 minus 9 times -3 minus -3 cubed over 3. And together that's equal to 36. And lastly, question 13, given the Lorentz curve, x equals 2.3, find the Gini index. So the Gini index is equal to 2 times the integral from 0 to 1 of x minus the Lorentz curve. So let's put this in. So it's 2 times the integral from 0 to 1 of x minus x to the 2.3 dx. That's equal to 2 times x squared over 2 minus x to the 3.3 over 3.3. Just add 1 to the power, divide by the new power. So this is 2 times 1 squared over 2 minus 1 to the 3.3 over 3.3 minus 0 plus 0. And we get 0.39. All right, that's it for this test. Thanks for watching.